want to look at arrangements. We're building towards factorials and formulas. So how many arrangements are there of 3 objects, 5 objects, and n objects? So we're building up to a general case here. Before I begin, I want to remind you that when I have an arrangement of objects, it implies no repeats. I can't replicate objects. So if I were to do this, I want to look at how many ways can I arrange 3 objects? Well, I have 3 choices for the first position, 2 choices, and then 1 choice. If I have 5 objects, I have 5 choices for the first, and I just go down by 1 because repeats aren't allowed. So just looking at those 2 questions, I see some patterns that I want to generalize. So my first pattern is I wanted 3 objects, I started with 3. I was looking for 5 objects, I started with 5. So following that pattern, if I'm starting with n objects, here I'm going to start with n objects. Okay, my next pattern is from 3 to 2 to 1, I'm going 1 less. From 5 to 4 to 3 to 2 to 1, again, I'm also going 1 less. So let's repeat that pattern here. So to go from n, 1 less, and then I go 1 less. And let's look at my last pattern that I see. When I reach 1, that means stop. When I reach 1, that means stop. So I know my last number here has to be stop, 1. So I'm going n, 1 less, 1 less. Now I don't know what n is, so I don't know how many times I have to continue this process. So I'll just do dot, dot, dot. Okay, so this way of arranging n objects, n, n minus 1, n minus 2, etc., all the way down to 1, has a special name. All of these have a special name, and they are called factorials. So factorials is a shortcut way of arranging all your objects. It's denoted n factorial, where n is a whole number, meaning it can't be negative, it can't be a decimal, or it can't be a fraction, because n is a number of objects. So in general, what it means is that you start with your number, whatever factorial you're taking, and you multiply by consecutive decreasing factors. So if I go back here, this 3, 2, 1 means stop can be short formed, notated as 3 factorial. This 5, 4, 3, 2, 1 can be denoted as 5 factorial. N, n minus 1, n minus 2, all the way down to 1 is just n factorial. So it's a shorthand way of denoting it, but it's also a quick way of calculating it. So on your calculator, we have a factorial button under our probability. So math probability 4 is the factorial, or if you have the CE, you can use alpha window 9. So if we go back to this 5 factorial, 5 times 4 times 3 times 2 times 1, let's do that on my calculator. So I'll clear this out. So if I wanted to evaluate that, I would do 5 times 4 times 3 times 2 times 1, and I would get 120. Using the factorial, there's a faster way of doing that. So we're going to go 5, and then math, over to probability, and I'm going to choose option number 4. So down to 4. 5 factorial. And that's 120. So it's just a shorthand way. For those of you with the CE, it's going to be 5, alpha, window, and then option number 9, factorial. Just a quicker way of getting there, but that's 120. So factorials are just a shorthand way of kind of denoting that, okay? And you can do that on your calculator as well. 0 factorial is going to be 1. The only way you can arrange 0 items is one way because you just don't arrange them. And then 1 factorial, if there's just one way of arranging things, it's one object arranged, there's just one way of doing it. So those are some special factorials. So let's use some factorials to evaluate an expression. We're going to do this without using our calculator. So I want to do 8 factorial divided by 5 factorial. So my tip for you is to start expanding the bigger factorial until you reach the smaller, and you stop when the factorials match. Now the reason that I do this is because the only way to cancel out a factorial is with another factorial. So 8 is the bigger one, so I want to expand the bigger one and stop when it matches. So I'm going to go 8 times 1 less times 1 less times 1 less, and I'm going to stop because it matches the factorial on the bottom. So 5 factorial divided by 5 factorial is 1, so I'm just left with 8 times 7 times 6. So multiply 8 times 7 times 6, you're going to get 336. So let's take this idea of doing it with numbers and do it with variables. Same process. Okay, I want to expand the bigger, stop till it matches the smaller. So I don't know what n is, but I know n plus 1 is bigger than n minus 1. So I'm going to expand my bigger factorial and stop when it matches my smaller. So I start with the first number, n plus 1, and then I go 1 less. So take away 1 from the 1 is 0. And then I go 1 less. And now I can stop because I have a match in the bottom. So since I have a match, n minus 1 factorial divided by n minus 1 factorial is just 1, and your answer is n plus 1 multiplied by n. Now I would just leave it like that, but if you cannot resist the urge to distribute that, I will also accept n squared plus n. Okay, now there's a really neat way of checking things in the calculator. All I have to do is take my original expression, I'm going to put that one into y1. I'm going to put what my final answer is, or what I think it is, into y2, and I'm going to see if it matches. So to check, the check always happens into the calculator, into the table of the calculator. So you can see original in y1, answer in y2. I go into the table, and for all permissible values, I see they are equal, so I know I've done the question right. Okay, let's try another one. N factorial over n plus 2 factorial. This time the bigger one is in the denominator. So wherever it is, I just want you to expand the bigger one. So we're going to leave the top alone. So let's expand n plus 2. So start with n plus 2 and go 1 less. So 1 less than 2 is 1. And then 1 less. And I can stop because I have a match. Okay, so because I have a match, n factorial divided by n factorial is 1. And that will be over n plus 2 times n plus 1. And again, I would just stop there, but since some of you love the distributive property so much, I know you're going to go one step further, and that's okay. I will accept this as well. 1 over n squared plus 3n plus 2. Okay, now that we've practiced factorials with expressions, let's add on a layer and make it an equation. So let's say I have n factorial over n minus 2 factorial equals 20. Same process. I'm going to expand the bigger. So n is bigger than n minus 2. So I'm going to start by expanding that. So I start with n, and then I go 1 less, and then 1 less, and I can stop because now I see in the denominator I have a match. Equals 20. So n minus 2 factorial over n minus 2 factorial, those are the same thing, and they divide to be 1. So I'm left with n times n minus 1 equals 20. So now, because it's an equation, I do have to apply the distributive property, and I get n squared minus n. Since it's a quadratic, I'll set it equal to 0. Now when I have a quadratic, I'm going to solve that by factoring, and if it can't be factored, I would go to my quadratic equation. So that one can be factored, so n minus 5n plus 4, meaning n can equal 5, or n can equal negative 4. Now hopefully you remember from when I first introduced you to factorials, I said n factorial, where n is a whole number. You cannot have fraction, decimal, or negative factorials. So this is not a solution. It's a solution to the quadratic, but not to the original equation. So therefore it's extraneous because you cannot take a negative factorial. So the only solution is n equal to 5. Okay, again, you can check this in your calculator, and the way that I like to check is by putting left side into y1, right side in y2, and look at the table when n equals 5 and see if they are equal. I really don't think there's a point in doing a question if you're not going to actually check to see if you're right. So I'm a big fan of the check. So left side y1, right side y2, look in the table at 5 and you can see they are equal for 5 but nothing else. So that tells me that 5 is my solution. Okay, we're going to come back to factorials in a minute. I want to talk firstly about permutations with repetition. So let's say that you have three objects, A, B, C. They are different. Okay, there's no repeats. I just want to know how many arrangements you can have. So for my first object, I have three choices. It could be an A, a B, or a C. My second object, two choices. So three choices, take away the one choice that I had before. And then one choice, three choices, take away the two previous one. 3 times 2 times 1 is 6. Let's practice our factorial here. 3, 2, 1 is really 3 factorial. Okay, so there are 3 factorial or 6 arrangements. I can actually list them all out. Here are my 6 unique arrangements. Now let's introduce a repetition. So we're going to take these A, B, C, A, C, B, etc., all 6 arrangements, there they are, and we're going to replace every B with another letter A. So I'm going to replace every B with a letter A. And I want to know how many arrangements I'm left with. Okay, so replace every B with a little letter A. Okay, that's a little bit messy. Let's clean that up a little bit. This is really what it, oh, let me try that again. Here we go. There we go. Let's clean that up a little bit, okay? So I really have AAC, AAC, ACA, etc. My question is, I started with 6 arrangements. Do I still have 6 arrangements? Well, if you look at them, AAC is the same as AAC. So this is actually the same. I'm not going to count it twice. That would be redundant. So that's the same. Looking at ACA, that's the same as ACA. That's redundant. I won't count that. And CAA is the same as CAA. So you can see I do not have 6 arrangements anymore. I really have 3 arrangements. So my question is, how do we go from 6 ways of arranging something to 3 ways of arranging things? It is half the number of arrangements. And that half the number of arrangements comes from the fact that I have repeated elements. I have 2 A's. So every one of these that I got rid of, it's because I have 2 A's. So 2 A's here is the same as those 2 A's here. And these 2 A's are the same if you flip it around as these 2 A's. So that's why I have repeated elements or arrangements that I had to get rid of. So if I have 2 letter A's, there's 2 choices for my first letter, 1 choice for my second letter. That means that there are 2 factorial ways of arranging those A's. So what we really need to do is divide by the 2 factorial ways of arranging the A's because they are redundant. So this would really be 3 factorial ways of arranging 3 objects divided by the 2 factorial ways of arranging the repeated elements. And this actually works for every scenario, no matter how many elements are repeated. So in general, if I have permutations with repetition, if there are n objects all together, and I'm only using this when I'm arranging all the objects, where A are alike, B are alike, and C are alike, I divide the n factorial ways of arranging all the objects by the ways of arranging the repeated elements. Okay, so I always divide by the ways of arranging the repeated elements, however many. There's not always necessarily 3. There could be 1, 2, 4, whatever it is. Okay, so my tip for you is anytime you're arranging all elements of a question or all objects in a question, always look for the ways to arrange the repeated ones if there are repeats, because the question will not specify. So always be on the lookout for repeats. Okay, let's look at this one. How many arrangements of all the letters of the word red deer? Okay, I'm arranging all of the letters of red deer, and I want to know how many arrangements begin with exactly 1 R. So very first thing I look at is look at the letters. There are 7 of them, and there's a couple of repeats. 2 R's, 2 D's, and 3 E's. So I'm going to do the arrangements as though there were no repeats, and then divide by the repeats. So I want to look at R, and then not R. Why am I doing R and then not 1 R? Because I'm exactly 1 R. So if that second letter was an R, it would be 2 R's, but I want exactly 1. So altogether there are 2 letter R's. Out of those 7 letters, if I take away the R's, I'm left with 5 letters to choose for my second letter. And then I have 5 letters left to arrange. 5, 4, 3, 2, 1. Or practicing what we just learned, 5, 4, 3, 2, 1. That is just a factorial. That's really just 5 factorial. Okay, so I'm going to take that, but I have to remember to divide by the ways of arranging the repeated elements. So I'm going to take my 2 times 5 factorial, and I'm going to divide it by the 2 factorial ways of arranging the r's, because there's 2 r's, the 2 factorial ways of arranging the d's, because there's 2 d's, and the 3 factorial ways of arranging the e's, because there are 3 e's. So I can put that into my calculator, and I get that there are 50 arrangements. Another nice little application of permutations with arrangements where repeated elements are involved is pathway questions. So let's look at this one. Mateo lives 3 blocks south and 5 blocks east of an ice cream store. How many different ways can he walk the 8 blocks home from the ice cream store? So because I'm a visual person, I need to draw a picture. So that's my tip for you. I want you to draw a picture of one possible route. Now, you can draw one, and it's probably going to be different than the way I drew it, unless we're weirdly connected, because there's lots of different ways, okay? So just draw one possible route just to kind of get a feel for what it looks like. So I'm just going to go like this. I'm going to go here, 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 and there. That is one possible route. So to describe my route, I would say I went down and then right, down and then right, down and then right, and then right, right. But that is only one possible route, okay? So really what this is I can shift around these letters. Like let's say, for example, I interchange these two. That would be an entirely different route. Right, right, down, right, down, right, right, down. That would be a different route, okay? If I were to trace that out just to show you it is different, I would go right, and then right, and then down, and then right, and then down, and then right, and then right, and then down. That would be a different route than I came up with before. Okay, so I can interchange those letters a whole bunch of times. So this is kind of like arranging the 8 letters where I have some repetition, and that's exactly how I'm going to solve it. Okay, to find all the pathways, I'm going to treat it as an arranging identical objects question. So all together I have 1, 2, 3, 4, 5, 6, 7, 8 letters to arrange. So I'm going to say 8 factorial ways of arranging those letters, but we have some repeats. If you look, we have 3-letter D's, so I need to divide by 3 factorial, which is the letter D's, and then divide that also by 5 factorial, which is the letter R. That should give me all the possible pathways. So I can plug that into my calculator, and I can see that I have 56 pathways from the ice cream shop going home. Okay, so everything that we've been dealing with in 11.1 is a permutation. And again, it is an ordered arrangement, order matters, of all or some of a set. So this can be denoted using the fundamental counting principle or using this notation NPR. P standing for permutation. NPR is the number of permutations of n objects taken r at a time. So it is a notation. That notation for permutation also has a formula attached to it. So the formula NPR on your diploma formula sheet is n factorial over n minus r factorial. So n factorial, the ways of arranging all of the objects. And then the reason we divide by n minus r is because those are all the objects we are not picking. So r is the objects that we are picking. We want to take out all the objects we're not picking. For example, if I have the arrangements of 5 objects taken 2 at a time. Applying that formula, I would do 5 factorial divided by 3 factorial. 5 take away 2 is 3. Because 5 factorial is all of them, but I'm only choosing 2 objects at a time, meaning I'm not choosing the other 3. That's why I divide by the 3 factorial. So any question that you can use fundamental counting principle for, you can use NPR. Now you can use NPR, the formula, or you can use NPR, the button. So there is a button, same location as where you did your factorial, and that is under your math probability menu, and it is option number 2. There's your NPR button. So if I wanted to evaluate 5p2, the arrangements of 5 objects taken 2 at a time, let's go into your calculator to do it. So I can do 5, and then I do math over to probability, down to option number 2, and I can do 5p2, which is 20. Or if I have a CI calculator or CE calculator, I can go 5 alpha window, and it's option number 7. And you'll get the exact same template and of course the same answer. Okay? So just another way that you can do it on your calculator or with a formula. Okay? So I want to look at some common permutations. Okay, common permutations. So NPN, that's just n factorial. So n objects taken all n at a time, that's the definition of a factorial, arranging all the objects. So for example, 5p5 is the same as 5 factorial. You can see they're both 120. If I have np1, well, that's just going to be n. That's n ways of arranging one item from n. So if you have n objects and you're taking one at a time, there's n ways of doing that. So for example, 5p1, the answer is just 5. So 5 and 5, just like n and n. Okay, np0, that's equal to 1. There's only one way of arranging no objects from n objects, which is just the one way of not doing it. Okay, so for example, 5p1 equals 1. So you can see 5p0 equals 1, just like np0 also equal to 1. Okay, so that's just to save you from having to put it in your calculator. You can know what the answer is. Okay, I want to look at this question here, and we're going to solve it in 2 ways. We're going to solve it with fundamental counting principle, and we're also going to solve it with our NPR notation. So I want to know how many different arrangements of the letters, we're arranging all of the letters, so I need to look for repetition, in the words tables can be made using at least 4 letters. So looking at tables, there are 1, 2, 3, 4, 5, 6 letters. And since I'm arranging all of them, I always want to look to see, do I have any repeats? And I don't. So I have 6 letters, no repeats. Okay, and I'm using at least 4. We've seen that word before, and remember that's a minimum. So at least means a minimum of 4 letters, which means I have cases. I could have 4 letters, 5 letters, or 6 letters. So I'm going to have 3 different cases. So using the fundamental counting principle, let's look at this. So let's look at the case of having 4 letters. So 6 choices for my first letter, 5 choices for my next, 4 choices, and then 3 choices. Okay, that's for 4 letters. Let's look at my case of having 5 letters. So 6, 5, 4, 3, 2. And then the last case is all 6 letters, which would be 6, 5, 4, 3, 2, 1. Or I could say 6 factorial. Okay, so I can put all of those together in my calculator, and you can see there it is. So I've got my first case of 4 letters. I have my next case of 5 letters, and my last case of 6, which I could have also used 6 factorial. I get 1800. So let's solve the same question using permutations this time. The NPR notation. Okay, so it's still a permutation because it's arranging it. Order is important. I still have at least 4 letters, which is still those cases of 4, 5, or 6 letters. But doing it using the NPR notation, it would look much more simple. So a little less writing, if you will. So if I'm looking at 4 letters, I'm looking at 6 letters taken 4 at a time. That's for 4 letters. If I'm looking at 5 letters, I have 6 letters taken 5 at a time. Or for 6 letters, I'm looking at 6 letters taken 6 at a time. So I can put that into my calculator, and I also get 1800. So it really matters to you. It's up to you which way you like to do it. Both ways are okay. So I just want to end this lesson here by using the permutation equation to solve for n. So I want to solve for n if np2 equals 56. A way of asking this in terms of a word problem, it would be how many objects taken 2 at a time are there if there are 56 unique arrangements, something to that effect. Okay. So I'm going to use my formula NPR, and in this case where R equals 2 and we're trying to solve for N. So I'm going to have, let's write it out and we're going to use our formula. So NP2 equals 56. So NP2 using the formula is N factorial over N minus 2 factorial, and that will equal 56. Well, in one step here, applying the formula, I'm back to where I started the lesson when we did questions like this. And when we did ones like this, we always started with the bigger, and we always want to expand the bigger. So n is bigger than a number, subtract 2. So I'll start with that, start with n, and then go one less, and then one less, and I can stop now because I have a match in the denominator. So since I have a match, n minus 2 factorial, n minus 2 factorial, those cancel to be 1. I have n times n minus 1 equals 56. So applying the distributive property, n squared minus n, I have a quadratic, so I'm going to set it to 0. And then I just factor. So n minus 8, n plus 7 equals 0. So n can equal 8, or n can equal negative 7. Again, remember, when we're arranging objects, we can't have a negative number of objects. So this is an extraneous root, meaning it's a solution to the quadratic, but not a solution to the permutation. So that means n is equal to 8. When it comes to equations, I always want to check. So I can check that in my calculator. xp2, so if x is 8, in other words, if I put in the 8 here, that's 8p2, and you can see that it is 56. So that's a nice way of checking. Now, if this question was a numeric response question, you wouldn't have to show all your work. You could actually use your calculator to come up with the answer. So since you know you can only arrange a whole number of objects, you can just enter it into your calculator and look in your table to see the value that makes sense. Okay, to summarize our lesson, n factorial is arranging all n objects. Don't use a factorial unless you're using all of them. Okay, when you are simplifying expressions with factorials, always expand the larger factorial and stop when it matches the smaller. Factorials are also useful for arranging repeated objects, so always be on the lookout for the ways of arranging the repeated objects because you need to divide by that in the last step. And in general, permutations can be solved using the fundamental counting principle, the NPR formula, or button on the calculator. So factorial is something that's new to you guys. You've seen the exclamation point in English, and so I thought it would be a really good joke to play on the English versus math use of an exclamation mark. So in English, we would say, I will eat 6. In other words, talking about the pie eating contest. And then the math interpretation of that would be, well, that's impossible because you can't eat 720 pies.